Sacred Heart High School welcomes you. Today we are going to study in Science-1, Chapter 1, Gravitation, Part 1. As we have learned, the phenomenon of gravitation was discovered by Sir Isaac Newton. As the story goes, he discovered the force by seeing an apple fall from a tree on the ground. He wondered why all apples fall vertically downward and not at an angle to the vertical. Why do they not fly off in a horizontal direction? After much thought, he came to the conclusion that the earth must be attracting the apple towards itself, and this attractive force must be directed towards the center of the earth. The direction from the apple on the tree to the center of the earth is vertical direction as the position of the apple, and thus the apple falls vertically downwards. The force on apple on the tree is towards the center of the earth, that is, along the perpendicular from the position of the apple to the surface of the earth. Now you can see it also shows the gravitational force between the earth and the moon. Now this you can see this can be concluded by saying that the position of the apple tree is changed. Then also you will see that the apple is falling vertically downwards, that is along the perpendicular from the position of the apple to the surface of the earth. Similar way in the third case also you can see that the force on an apple on the tree is always towards the center of the earth, that is along the perpendicular from the position of the apple to the surface of the earth. So we can conclude that it is always perpendicular from the position of the object to the surface of the earth. Newton thought that if the force of gravitation acts on apple on the tree at different height from the surface of the earth, can it also act on objects at even greater heights, much farther away from the earth, for example, like moon? Now let's understand the difference between gravity and gravitation. Now you can see in the picture, suppose we consider a planet Earth and Mars. So we can define gravitation is the force of attraction between any two bodies of the universe. For instance, example here, Earth and Mars. Then what's gravity? Gravity is the Earth's gravitational pull on any body lying on the Earth's surface. Next we shall see that planetary motion had been observed by astronomers since ancient times. Before Galileo, all observations of the planet's position were made with naked eyes. By the 16th century, a lot of data were available about planetary positions and motion. Johannes Kepler studied this data. He noticed that the motion of planets follows certain laws. He stated 3 laws as describing the planetary motion. Now these are known as Kepler's laws of motion. Now we shall see each law one by one. Now we know that the orbit of the planet is always in an ellipse. Now what is an ellipse? Now ellipse has two focal points. If you consider here the planet which is moving around the sun or orbiting around the sun. Now if you see over here, the orbit of the planet is an ellipse with the sun at one of the foci. Since ellipse has two focal points, so we can consider sun to be at one of the focal point. Now this is considered to be as Kepler's first law. Now before that, we would like to discuss about the speed of the planet around the sun. Now you may see that in the picture that the speed of the earth around the sun is not constant. That is, when the earth is closer to the sun, the movement is faster. And when the planet is farther away from the sun, the force of gravity is less and hence the motion is slowest. So we can say that the speed of the planet or earth in the orbit is not constant. Now we'll move on to the Kepler's second law of motion. Now if you consider over here, let us consider or let us represent sun as S and consider the position of the planet at A, as you can see in the first picture, or in the second picture we can consider as P1. So the line joining the sun and the planet be as P1, or as in the first case as AS. Now in 30 days or the time period 1 month, the planet moves from the position A to B. That is, in the second case, it can be considered as from P1 to P2. So the area we can consider as ASB, or as P1 as P2, represented by an area as A1. So we can say that the line joining the planet and sun sweeps or covers an area ASB or P1 as P2 in 1 month. Now second instance we can consider as suppose. Now consider the planet has reached from P2 to P3. Now here we will consider the line joining the sun and the planet be P3S. Now in 1 month the planet moves from P3 to P4. So it has covered an area as P3, P4. So the straight line, that is P1S and P3S, sweeps equal area in equal interval of time, that's 1 month or 30 days, that is area P1S P2 and P3S P4 are equal. That is A1 is equal to A2. This is considered to be as Kepler's second law. So we'll just revise the Kepler's second law. It states that The line joining the planet and the sun sweeps equal areas in equal intervals of time. Now, as you can see, the shape of the orbit is elliptical. Now, let's consider time taken for one revolution by the planet around the sun be t. The distance from the planet to the sun will be changing. That's when it is close to the sun, the distance is shorter. When it is far away from the sun, the distance is larger. So the distance will be changing. Now let's remove average distance as r. Then we can say that t square is directly proportional to r cube. So that is t square upon r cube is equal to constant, that's k. So Kepler obtained this law simply from the study of the position of planets obtained by regular observations. He had no explanation as to why planets obey these laws. Now we'll see the next how these laws helped Newton in the formulation of his theory of gravitation. Now, what is Newton's universal law of gravitation? Now, all the consideration, including Kepler's laws, led Newton to formulate his theory of universal gravity. According to this theory, every object in the universe attracts every other object with a definite force. This force is directly proportional to the product of the masses of two objects and is inversely proportional to the square of the distance between them. Now let's understand this with the help of the picture. Now in the picture you can see two objects with mass m1 and m2 which are kept at a distance r from each other. Now mathematically, the gravitational force of attraction between these two bodies can be written as F, which is directly proportional to m1, m2 and inversely proportional to r square, or F is equal to g m1 m2 upon r square, where the g is the constant of proportionality and is called the universal gravitational constant. So the above law means that if the mass of an object is double, the force between two objects also doubles. Also, if the distance is double, the force decreases by a factor of 4.